All right, folks, it's back in action here. In this video, we are going to cover this entire front of your foldable. So there's going to be a lot of information on this. Make sure to pause and jot down questions if there's at any point in the video that you are confused, because there's going to be a lot of information on this video. Okay, we're going to start here with the top. We're working with perpendicular bisectors. Specifically, all the segments that we're going to work with in this chapter are going to be inside a triangle. You'll notice here that in this, in our pictures here, I have three types of triangles. Yours is probably already marked with a right angle. This middle one is in fact a right triangle. So we've got all three types of triangles. We have an acute triangle, a right triangle, and an obtuse. And we're going to first look at this new segment called a perpendicular bisector. Now, we've done perpendicular bisectors when it's just of a segment, but now we're going to look at what happens when we have a triangle. So just as we've been doing up until now, a perpendicular bisector is a line that is going to be perpendicular. You can just use your symbol here. There's nothing wrong with that. A line that's going to be perpendicular to a side, okay, and it's going to pass through the midpoint of that same side, okay? So in these figures, if this is a perpendicular bisector, then what I know is that this is going to be perpendicular, and this segment, this portion, and this portion are going to be congruent. I could continue that, and I could say this is a right angle, and this portion will be consistent with or congruent to this portion. Now you'll notice that I'm drawing these extra little lines in because we don't want to try to just mark little congruence marks, because these extra intersections will be confusing to us otherwise. We can also go on to say that this is a right angle and these two segments are congruent. We can continue that process with all of our triangles. I would have a right angle. Again, I'd have a congruent and a congruent. And I'm going to have a right angle and a congruent and a congruent. And then we would have our right angle and our congruence and our congruence. Notice that I'm drawing a different number of tick marks each time. On our next one, I would have my right angle and I would have a congruent and a congruent. I would have my right angle and I would have a congruent and a congruent. I know this is very repetitive, but it's really important. And I would have a right angle and my congruence and my congruence. Okay, now notice that in all of these cases, the three perpendicular bisectors are intersecting in a single spot. That is called a point of concurrency, okay? The point of concurrency has a special name called the circumcenter, and you need to know it. You need to know that circumcenter is for perpendicular bisectors. So circumcenter, okay? The circumcenter is going to be equidistant, that means the same distance, to each of the vertices of the triangle. Now, we're going to use that circumcenter to circumscribe a circle around the triangle. Now, we're going to do this in class, but this will be the center of a circle, and each of the vertices of the triangle will be on the circle itself. We're not going to do that right now. We'll do it in class together. Okay, now I want to get into how we can apply this and problems that we can do with this. So the first thing that we're going to have is this perpendicular bisector theorem. We are not going to do a proof with this, so the name is less important than all the information that I'm going to have here. The perpendicular bisector theorem says that if a point is on a perpendicular bisector of a segment, okay, then that point is going to be equidistant from the endpoints of the segment. So, quick example. In this figure, if FS is a perpendicular bisector, first of all, I know that's a right angle, and these two segments are congruent. Now, if this point F, okay, this point is on the perpendicular bisector, clearly here, and what that means then is that if I drew in this FA and this FT, that these two segments would be congruent. So FA is going to equal FT. Okay, because any point along this perpendicular bisector will be equidistant from these endpoints. Now, the converse is also going to be true for us, okay? If a point is equidistant from the endpoints, okay, so if it is equidistant from the endpoints, then it is going to be on the perpendicular bisector. So, for example, in this figure right here, if this point W is equidistant, so WE is equal to WT, so we could mark that. If those two segments are congruent, then we would know that WR is a perpendicular bisector. Okay, now let's look at how we can do some solving with this. So if this ME is supposed to be a perpendicular bisector, then I know that I have a right angle, and I know that these two segments are congruent. So there's two things that I'm going to know are true on this problem. I know that 2x plus 5y is going to equal 90 because it made that nice right angle. And then I also know that 3x plus 17 is going to equal 5y plus 27. Now we've seen this before. I don't have a single equation that is only in terms of one variable, so I'm going to need to use both of my equations to do my solving. Now this one's a little bit unique because what I want you to notice is that both problems have this 5y. So what I'm going to actually do is I'm going to solve each of these for the 5y, and then we're going to use that as a substitution. It's just a different strategy. So I'm going to say 5y is 90 minus 2x. And on this one, I'm going to say 5y is equal to 3x minus 10. Now, since both of these problems equal 5y, they're going to equal each other. So 90 minus 2x is going to equal 3x minus 10. So that's going to give me 100 equals 5x. So x equals 20. Okay. So now I have x equals 20, and I can just substitute that into any of my equations that I want. I'm going to choose to go and say 5y then is equal to 90 minus 2 times 20, so 90 minus 40, so 5y equals 50, or y equals 10. So we've got x equals 20 and y equals 10. Okay, so you're going to see those types of problems, and you just need to remember that you have two congruent segments with a perpendicular bisector and you have a right angle. Now the last thing we're going to do, and I know this video is long, but just hang with me, we're going to do some coordinate geometry with our points of concurrency, and we are going to algebraically find this circumcenter. Okay, now I've written this to be kind of nice, so it will have a pretty answer for us, but you do, as always, have to do the actual algebra. So we're going to plot our points, -2, 1, that's going to give me A. I'm going to come over here to 7, up 4, and that's going to give me B. And I can quick sketch that in a little bit. I'm doing it on an iPad. It's a little bit harder for me to do. Also, you know, we've talked in class, like I'm having a hard time writing these days. So there we go. So there's our triangle. Yours hopefully looks better because you've got a nice straight edge there. Now, what we're going to do is we need to find the intersection for two perpendicular bisectors. So we're going to write the equation for a perpendicular bisector. It doesn't matter which one you do, but it is good for you to think through which one you're going to do. So for example, I'm going to write the equation for the perpendicular bisector of segment AC. That means that I need to find the midpoint of segment AC. So I'm going to first find my midpoint. Always remember to label your work. So our midpoint is going to be our -2 plus 0 over 2, and our 1 minus 3 over 2, because we're finding that average, and that's going to give me the point -1, -1. I also am going to find my slope. And when I find my slope, that's going to give me a 1 plus 3, because I'm flipping that minus a negative, and a -2 minus 0. So the slope of AC is actually -2. So my perpendicular slope is the one that I actually want to work with, and that's a 1/2. Okay. So that equation is going to give me, and I'm a little bit scrunchy here on my space. That equation is going to be y equals, oops, sorry, meant to do my y plus 1. So y plus 1 and my 1/2 and my x plus 1. I'm really sorry I'm having such a hard time writing here, so it's making it hard for me to fit it in that space. So I'm just going to leave it like that for now. Now the second perpendicular bisector I'm going to do is the one for BC. So again, I'm going to find my midpoint. and my midpoint's going to be 7 plus 0 over 2, and 4 minus 3. I'm just using the ordered pairs from up above. If you need to pause this. Okay, that's going to give me kind of an ugly looking midpoint, but don't worry about it. It's going to give me 7/2. Remember, absolutely no decimals here. So there's my midpoint. Now I'm going to find my slope. My slope of BC is going to be 4 minus that negative, so 4 plus 3, 7 minus 0. So it's going to be 7 over 7 is going to be 1. So my perpendicular slope is a -1. So my equation is going to be y minus 1/2. Again, don't worry that this looks really bad for right now. And x minus 7/2. Now, when we go to do this system of equations, it's really not going to turn out to be too bad. So I'm going to take this first part here. Okay, I'm going to take my first part here, right here, and I'm going to take this 1 and I'm going to move it over. So I'm going to have 1/2 x plus 1, not distributing, minus 1. And that's going to equal, I'm going to come over here and I'm going to take the 1/2 and I'm going to move it over. And I'm going to have a negative x. Actually, I'll have my negative and I'm going to say an x minus 7/2. You could distribute if you want. And now I'm going to have a plus 1/2. From here, I can multiply everything by 2. It's not even a really bad number to have to multiply by. And that's going to give me an x plus 1 minus 2. And then I'm going to have a minus 2 and an x minus 7/2. Notice I'm not trying to do everything all at once. Plus a 1. Now I can start cleaning things up. On the left side, it'll become an x minus 1. On the right, I'm going to have a negative 2x plus a 7, and then plus my 1. Now, this is going to be pretty easy to clean up. So I'm going to have a 3x, move everything over to the other side. I'm going to have a 9. So sure enough, I get an x equals 3. So that's pretty nice. Now, I just need to take that and I need to substitute it into one of my equations. Obviously, this is the cleaner one to try to do. So I'm going to say y equals 1/2, and 3 plus 1 is 4. And then I'm going to have that as a minus 1 because I want to move that 1 to the other side. So I get a y equals 1 when I'm all done with that, because 1/2 times 4 was 2, and 2 minus 1 is 1. So my final answer is this x and y together is a beautiful ordered pair, 3, 1. And when you come to class, what we'll do is we'll plot that and I'll show you how we can even look at it and have it make even more sense to us. So what I want you to do before class is I want you to spend some time making sure that you understand all these steps, that this process is readable, that you understand how to get the equations for each of these and solve the systems, and jot down any other questions you might have.